The complete guide to fossils and fossil collection. And in this reading exercise today, we are going to. I wonder if my movement changes the direction of this camera. I think it changes a bit. We are trying to see. Does it change it? Or maybe it's just the direction. It does. See, it's moving. I don't know how it controls, but it's a great artificial intelligence feature. See, it's trying to cover me up into the frame. Yes, it can do up to this, and maybe this. Yes. Anyways, the chapter today is plants. Most biologists offer the defining feature of kingdom planting as photoautotrophism, or making one's own food with light, absorbing minerals and other raw materials from the surroundings and using captured sunlight energy to convert these to sugars and nutrients. Fossils cannot show any of this directly, but the anatomy of fossil plants is often immediately comparable to their living cousins. This section aims to trace the appearance of the main plants groups through time, charting increasingly complex structures such as roots, stems thickened with woody fibers, and fronds or leaves. Much of the classification is based on mode of reproduction, from spores in earliest roots such as mosses and ferns to the cones or gymnosperms. Angiosperms, broadly meaning enclosed seeds or seeds in receptacles, were the last major plant group to appear in the Cretaceous. They now dominate as flowers, herbs, and broadleaf deciduous bushes and trees. See, I'll show you the picture. Since this was a small chapter, we are going to continue with the next two, early plants. The very first life on Earth was mainly microscopic. Yeah, we all know that. It would have been a big deal since the evolution of life theories were being postulated and people believe we have been just dropped out of heaven. So it was really radical and challenging to the religion. The first multicelled plants appeared in the sea perhaps around 1 billion years ago. They are usually known as algae, the simplest category of plants, lacking two roots and leaves and reproducing by simple spores instead of flowers and seed-containing fruits. Well-known algae today include sea lettuces, rags, kelps, ovids, and dulses. Mixed algal Shedets deposit. Shedets has long been something of a mystery. It has been interpreted as a coral of the tabulate group or an encrusting sponge of the coralline demosponge type. The specimens are often combined with encrusting algae rich in the mineral calcium carbonate, making the right form of limestone. Similar fossil structures have been the stromatoporoids or layered pores, and these in turn show similarities to relatively new identified groups of living sponges, the encrusting sclerosponges. Shedets may well have been a sponge rather than a coral. However, in fossils it is often difficult to differentiate between the algal, poriferan, and coral elements. Similar algal shedates carbonate accumulations from the Eli Basin, dating to the mid to late Carboniferous, are found along the western edge of North America. Shedet beds are also known as northern England, and several European regions include Germany and Poland. Carboniferous algal deposit. Like many simple plants, some types of algae do not contain hard materials such as lignin, nor do they produce tough, resistant structures such as nuts or pollen grains. Usually they are preserved in detail only if they incorporate some type of resistant mineral such as silica, chalk, limestone into their bodies or thallium. In some examples, the interest in the incested form shows a tough wall developed to resist drying or similar adverse conditions. However, algal fossils have an immense time span extending back to the Precambrian period, more than 540 million years ago, and have been used as index or indicate fossils to date marine deposits, especially in search for petroleum oil. Coelosephyridium. Calcareous algae such as Celospheridium lay down deposits of chalky limestone minerals and gel-like substance within and sometimes around their tissue. This gives the plant a stiff, stony feel and aids preservation. This is common in certain parts of northern Europe, especially Scandinavia. It forms mixed beds along with other algae such as Mastropora, Cyclotrinus from its original identification as a Coeliotrina, a member of the Echinoderm group, but now regarded by some of the authorities as a siphonia algae and with various encrusting animals in vertebrae such as sponges and corals. Algal stromatolic limestone. Fossilized stromatolites or layered stone were once thought to be produced by tiny animals known as protozoans or by inorganic process of mineral deposition. However, comparison with the rocky deposits found along many warm seashore today, famously Shark Bay in Western Australia, reveal that these humped or moon-like structures, generally varying in size from that of a tennis ball up to that of a family car, usually have an organic origin. Tiny thread of green algae and blue-green algae thrive in tangled low mats covering themselves with slime and jelly for protection. These growths trap sand, silt, and other sediments as well as fragments of shell and other organic matter. New algal mats grow on top as the ones below harden and slowly the moon builds up as a multi-layered stromatolite. In calm waters, the stromatolite shape is often rounded, resembling a burger bun, while strong currents cause them to elongate like French baguettes, lying parallel to the current's direction. I'll show you the pics, which and the credit goes to Complete Guide to Fossils and Fossil Collection by Hermes House. Do buy this book. This is a great book if you're interested.